All right, so here's another problem for 6-3, and I want to do a word problem because we haven't done one of those in a while. Okay, so a dietitian needs a plan to plan a diet for a patient using two different food combinations to meet the patient's needs. Each container of food A contains 4 units of additive 1 and 2 of additive 2. Each container of food B contains 2 of additive 1 and 4 of additive 2. The patient needs at least 10 units of additive 1 and at least 12 units of additive 2, blah, blah, blah. And then we have our costs. So where are we going to start with this? Let's start with a little chart. So we have additive 2, additive 1. We have food A and we have food B. Okay, and this one has 4 units of additive 1, and it has 2 units of additive 2, and this food B has 2 here and 4 here. Right, 2 units, yep, 4. And then we know that this has to be greater than or equal to 10, and additive 2 has to be greater than or equal to 12 because it's at least. So it could be that or bigger. All right, and then we know our objective function is going to be 6x1 plus 10x2 because it says, oh, and I shouldn't call that P, I should call that cost. Okay, how many containers of each food should they use to meet and have the minimization of cost at $6 for food A and $10 for food B, and I just call this X1, X2. So whatever we're talking about for food A and B, that's going to be our X values. Okay, so let me go. And then, so this is going to form our, basically our formulas here. So we know our cost. So let's write this one out too. So it would be 4x1 plus 2x2 is greater than or equal to 10. 2x1 plus 4x2 is greater than or equal to 12. And we have to double check. We want to minimize our objective function, and everything better be in the form greater. Okay, that becomes really important in the next section, but we do have to check that. It has to be greater, greater. And then we also have our x1 and x2 are greater than 0. I'm not going to write it. I'm being lazy. So where do we start with our dual problem? We write out a matrix. We transpose the matrix, write a new problem with our y's, and solve that and look for the slack. So let's write our matrix. So we always do our objective on the bottom. So we're going to go 4, 2, 10. Oops, 2, 4, 12. And then this last one here, we're going to do as 6 with the x1s, 10, and 1. Then we need to transpose it. This one goes down. So 4, 2, 10, 2, 4, 12, 6, 10, 1. Okay, now what was our next step after we transpose? Was to write our dual problem. So we're going to max now the profit of 10y1 plus 12y2. That comes from the bottom. And it's subject to these two, which will be 4y1 plus 2y2 is now less than or equal to 6 because it's going to be max. Max is less. And then 2y1 plus 4y2 is now less than or equal to 10. All right. This is our problem that we now have to use simplex to solve. So let's set up our initial Tableau. Oh, we should do our slack variables first. So slack variables, this one here is going to be 4y1 plus 2y2 plus x1 equals 6. Bottom one, 2y1 plus 4y2 plus x2 equals 10. And then we have negative 10y1 minus 12y2 plus p equals 0. We want p to be way over on the side there so that you can see where the zeros would be in your matrix. The little gaps. Okay, so there. Here, I need to see that to be able to write the next step. There we go. So our initial tableau 4, 2, 1, 0, 0, 6, 2, 4, 0, 1, 0, 10, negative 10, negative 12, 0, 0, 1, 0. Okay, it's a dual problem, so we write a line, not a dotted. All right, so this represents our y1, our y2, our x1, our x2, and our p. Right, where is our first pivot? Well, the largest is negative indicator is negative 12. 10 divided by 4 and 6 divided by 2, this is 3. 10 divided by 4 is 2 point something, right? So that one's going to be smaller. So here's our first pivot. What do we do to it right away to make it to work with it? Is to make it a 1. So we're going to divide by 4 on that middle row. Oh, and 10/4 does reduce to what? 5 halves. So I just thought 10/4. Okay. And then the bottom, negative 10, negative 12, 0, 0, 0. Okay. So we're here. And our pivot is here. So now we want to make the zeros here and here. So we're going to use 2 and negative, or 2 and positive 12. So negative 2 times row 2 plus row 1, replace on row 1. And then we're going to do 12 times row 2 plus row 1, replace on row 3. Oops, plus row 3. Timesing by row 2, adding it to row 3, replacing it on row 3. Okay, let's do that real quick. Real quick. None of this is quick. Alrighty. So negative 2 all right, negative 2 times this is going to give me negative 1 plus the 4 will give me a 3. Okay, negative 2 times 1 and 2 make 0. Negative 2 times 0 is 0, plus 1 is 1. Negative 2 times negative or positive 1/4 is negative 1/2. Plus 0 is negative 1/2. Times by 0, add 0, 0. 5 halves times negative 2 is negative 5. Negative 5 and 6 make a 1. Middle row stays the same. Okay. And the bottom row, we're going to times by 12. So 12 times 1/2 is 6. 6 and negative 10 make negative 4. 12 times 1 is 12, plus that is 0. This one will be a 0. 12 times 1/4 is 3. Plus 0 is 3. 12 times 0 is 0, plus 1 is 1. 12 times 5 halves, the 2 goes into 12, 6. 6 times 5 is 30. Hope I didn't confuse you with my method there. Whoopoo! All right. Unfortunately, we have a second pivot. That's pretty common, right? So here's our next pivot. So 5/2 divided by 1/2. So you'll have to flip that second one and divide there. And then this would just be 3. Oh, no, it's 1/3. Duh. So if I flip this one over in times, you'd get 10/2, which is 5. So what's smaller, 1/3 or 5? Definitely 1/3. So this becomes our pivot for the next one. So let's divide by 3. Negative 1/2 times 3, or you times just the denominators. Don't make that harder than it is. 1/3. Okay, middle row stays the same, and the last row stay the same. Okay, and there's our pivot still. So let's get rid of these two by making them 0. So we'll use negative 1/2 and 4. Okay, so we're going to do negative 1/2 times row 1 plus row 2, replace on row 2. Then we're going to take 4 times row 1 plus row 3, replace on row 3. So our top row stays the same. All right, negative 1/2 times 1 plus that is 0. Negative 1/2 times 0 plus 1 is 1. Negative 1/2 times 1/3 is negative 1/6 plus 0 is negative 1/6. Negative 1/2 times negative 1/6 is positive 1/12 plus 1/4. Oh, let me get out my calculator. 1/12 plus 1/4. I could get the common denominator is 1/3. I didn't want to get a common denominator. Calculator. Okay, so then 0 times anything plus 0 is 0. And then negative 1/2 times 1/3 is negative 1/6. So negative 1/6 plus 5/2 is going to give me 2 1/3. I like it to be improper, so it's 7/3. Okay, bottom row, we times our 4 by the top and add. So this would be 0. 4 times that is 0. That 4 times 1/3 is 4/3, plus 0 is 4/3. 4 times negative 1/6 is negative 4/6, plus 3. So plus 3 is going to be what, 2 1/3 or 7/3? A lot of fractions. I think that's part of why I did this one too. 4 times row 1 is 0, plus 1 is 1. 1/3 times 4 is 4/3. So 4/3 plus 30 is 94/3. I wonder if that's the answer I got. Oh, I hope so. Sure is. All right, so this was a dual problem. What's our solution to our dual problem? Our solution is x1, x2, so let me write that. x1 equals 4/3, x2 equals 7/3, and our minimum cost is going to be, what is 94 divided by $31.33. All right. So if we go back to our original problem, we would say we can't buy part of a container, right? So 4/3. So 4 divided by 3 is the closest. It's 1.3, right? So let me do this. 1.3. And this one, 7/3 is about 2.3. right? And you can't go, I would like 4/3 of food one, right? Not gonna work, or food A. So we're gonna buy 2 containers of food A, because this was food A. And we're going to buy 3 containers of food B, because you always have to round up to get enough of the stuff that we need. And that makes our cost a little bit different. So if I buy 2 food A's, and I buy 3 food B, going back to the original, the cost won't be $31 because I have to buy 2 and 3. I can't buy 4/3 and 7/3. So if you go back to your cost function, it was equal to 6, right? It was like 6. I don't remember what our original, yeah. If we do 6, it was 6x1 plus 10x2s. Okay, so we do 6 times 2 plus 10 times 3. For some reason on my notes, I changed that to a 1. I don't really know why. It's going to give me 42. So our true minimum cost is $42, not 31, because we can't buy part of something. Okay, so there's a word problem and kind of getting that answer out. So hopefully you found that helpful. And if the sound's a little off, I apologize now.